And the last thing we were going to do today was just to run through using desktop Scimap and a little geoprocessing tool that we've made to hopefully make it a bit more accessible and a bit easier, and hopefully save you some time if you're running desktop Scimap. So I'm assuming that most of you are familiar with Scimap, so I was just going to more demonstrate how to use the tool rather than explaining about the model. But in case you're not, I have posted in the chat a link to a video called Scimap in under 7 minutes that Simrini at Durham University did, that gives you a bit more of an overview of the kind of theory behind it and how the model works and what it's showing you. So just to say before I start, Scimap's available in 2 formats. There's the My Scimap tool, which is an online web tool that you can use to run Scimap, and you can also run Scimap in desktop GIS. So which one should you choose to use? Well, My Scimap runs at a resolution of 20 meters is the grid resolution, so it's relatively coarse. So it's good if you want to run quite a large area quite quickly. Its other huge advantage is that it has the DTM uploaded into the model, so you don't have to access any digital terrain data. The drawbacks are that currently there is a kind of limit on the size of catchment that My Scimap can cope with before it falls over, and I've generally found that that's up to about 1,500 square kilometres to 2,000 square kilometres, somewhere in that region. It will fail, and also because it's at that 20-metre resolution, it is relatively coarse. I do think Scimap works a lot better if you run it with more detailed topographic data, such as LiDAR data, because that gives you much more clearer indication of the flow pathways and where the risk is coming from. So in both those cases, if you want to run it for a much larger catchment or you want to run it with more detailed topographic data, then you really need at the moment to be using the desktop Scimap to do that. Which runs for the fine sediment risk. So that's the one that I'm going to show you today with the tool that we've developed. So I'm just going to take you through the whole process of how to run Scimap using the desktop. So if I just share my screen. And so the first thing you want to do, if you haven't done it already, is download the Scimap tool. So you can get that from the Scimap website, which is just scimap.org.uk. And if you scroll down, you'll come to this bit with the framework where you can see the links to the various tools. So I should have also added that they do also have an FIO Scimap, which is a web-based tool for running the risk of looking at fecal indicator organisms. But for today, we're going to focus on the desktop one. So if you click on where it says Windows version to get that, you just need to register your details and click subscribe, and then it will send you a link that you can download the files. So it downloads the tool, and it also downloads a piece of open source GIS software called Saga GIS, and so you'll have access to all that. So it downloads, and wherever you've saved it, if you go to that folder, and you just probably click through the folders, they'll probably save like this. If you scroll down until you find the application execute file here, if you double click on that, it will open Saga GIS. And the first thing to check when you've loaded it is if you scroll down this modules pane on the left hand side, just check that you can see the module that says Scimap risk maps. Have encountered a problem a number of times. The first time you sort of download it and install it, that might be missing. If that's the case when you do it, if you just go to modules at the top and load module library and then search through that folder that you downloaded, you want to find this one, Scimap DLL, and if you click that to install, it should hopefully then appear in that module library, and it should load the next time you do that. But before we can run the model in Saga, we need to do some data processing in desktop GIS first. This is because the format that you put the input data into the model has to be in what's called an ASCII file. It's a kind of, sort of text file for holding the data. So we need to convert our input data sets to that format before we can use it. So I'm going to show you how you can do that in Pro using this geoprocessing tool that we've developed that we can send around on email afterwards, or you can just get in touch to ask me for it. So the first thing we're going to do is we're going to add the data that we need to run Scimap. So there's 4 pieces of information that you need to run the model. We need some topographic data for our catchment, so a digital terrain model, and in this example we're going to use 2-meter LiDAR data downloaded from the Environment Agency. You then need some land cover data, so you can generate your risk of erosion based on the land cover. So we're going to use the CEH 2015 land cover map that's available in the CABA data package that you should all have access to. We need some rainfall data, so we're going to use the average annual rainfall from 2010, I can't remember what it is, from 1981 to 2010, and then you also need a catchment boundary file, a shapefile for your boundary. So we're just going to add those data sets first to our map. So I'm just going to add the catchment and the DTM. And I'm not going to show you here today how to download the LiDAR and access that, but if you're not familiar with how to do that, then Kat's made 2 really excellent videos, and I posted the link before in the chat to those if you want to have a look at how to download the LiDAR and how to stitch it together into a mosaic tile, and those are both really helpful to guide you through that. Then if we go and add from our data package, so I'm just running this test for the Glenridding subcatchment in the Eden. So if you go into your CABA data package folders and into the Esri and into characteristics, you can add the annual average rainfall, and also go down land cover 2015, and it's the vector layer that you want. So if we just add those to the map. So one thing I wanted to show you here was with the rainfall data, because I've spotted this now on a couple of catchments. I think when we've clipped the data, it hasn't quite clipped accurately, and in some catchments, if your subcatchment that you're interested in running the model for is over on the edge of your whole catchment, it might have missed off the rainfall data and you might not have full coverage. If that's the case, if you just drop us a message, we can just send the full national rainfall layer to you, so you've got that and you can use it. So I'm just going to remove that one there, and I'm just going to go back and add the national rainfall one instead. So now we've got the data added that we need to run the tool. The next thing is to add the toolbox with the geoprocessing tool in that we've developed. So if we just go to Insert here and Toolbox and add Toolbox, just navigate to where you've saved it and just click OK. That'll add the toolbox there for you. So I just thought it was worth showing you the tool before, so you can see it contains 2 tools. We've got a create Scimap inputs that's going to convert all those layers we've just added into the right format to put into the model, and then we've also got a convert Scimap outputs, so when the outputs come out of Saga, it'll quickly convert them all in one go back from ASCII files into files that you can view and symbolize in Arc Pro. So if I just click on one of them to open the model. So this is built in Model Builder, like the demo that Kat did a few months ago when we had that session on that. So just to show you basically the processing steps that we're going through here. We're taking our input elevation data and we're clipping it by the catchment boundary. and then we're converting that into an ASCII file. And then we're doing the same with the rainfall, we're clipping it by the catchment boundary, converting it into an ASCII file. And we're also, with the land cover, because it's a vector layer, we're first converting it into a raster data set. We're then clipping it by a catchment boundary. We're then reclassifying our land cover by the Scimap risk weightings. So that's the risk that each land cover is assumed to sort of pose an erosion risk. So I think with the standard risk weightings, arable land is ranked the highest, followed by improved pasture, and then the risk gradually reduces for other land classifications. And there is one slight little oddity in here that I'll explain a bit more, is that the Scimap risk weightings are scaled from 0 to 1 with decimal places, but the reclassification tool in ArcPro can only work with integer numbers. So I've multiplied them by a factor of 100 for the reclassification, and then it just divides them by 100 and turns it back into a floating point layer with decimal points, and then it converts it into an ASCII layer as well. The tool also makes sure that all these three layers snap together, so they overlay each other, and the order of the tool also should help with an issue that some of you who've used desktop Scimap before might have run into, where when you upload your layers into Saga GIS, they're not in the same grid system. The extent of the area they cover is slightly different, and if they end up in different grid systems, then the tool won't work. So hopefully this processing tool has resolved that issue, or at least limited it. We've had a number of people testing it now, and so far they haven't run into any issues, so fingers crossed it's helped resolve that issue slightly. So want to run the tool, we can just open it from here, or you can go to analysis and search for Scimap, and we want to create Scimap inputs, which should open the tool down the side here. So first we want to set our output workspace where we want it to save our outputs, and that has to be a folder. It's not a geodatabase because the ASCII files can't be stored in a geodatabase, so we just want to set up a folder. So I would normally set up a new folder within the project and call it something like Enridding Scimap inputs. So I'm just going to choose that as my output workspace. And then I'm going to add my catchment boundary, my DTM, my rainfall layer, and then my land cover layer in the tool. And then the next thing is it's asking you for the attribute field within the land cover data set that holds the land cover classes. So if you're using the 2015 CH data from the data package, then it's the one that's called grid code that you want to choose in there. If you've used your own land cover data, it might be something different. The next thing that we have as we scroll down in the tool is the reclassification tool table that's going to apply the land cover erodibility risk weighting to the different land cover classes. So you can see the CH land cover map is classified into 21 classes, and I've currently the tools set up with the default of the standard Scimap risk weightings, and I'll show you in a minute, just while the tool's running, I'll show you the table that's got the risk weightings in. So these are the standard ones, but you can change them if you want, if you think certain land uses in your catchment might have a higher risk. So for example, I know number 2 relates to coniferous woodland, and at the moment it's got the same risk weighting as broadleaf woodland. So you might think, I want to increase that in my catchment. So I'm going to put that risk up to 15. So they're scaled between 0 and 100. So 3 is arable land, so that's got the highest risk at 100. Number 4 I know is improved pasture, and I might think actually that is a lot higher. So I'm going to make that up to 75. If you do change the risk weightings and you want to save it so you can use the same again in another catchment. If you just click on the little save button here, it will ask you to save your remap table. So you can just save it there, and then if you'd opened this again and you wanted to get hold of that new table, you can just click on open there and find your table and load it in there. So I'm just going to go back and change these back to the standard ones. And then the final thing you need to do is set the cell size or the resolution that you want the model to run at. So because I was using 2 meter LiDAR here, I am going to set the cell size to 2 meters. So that's going to make all the layers into a 2 meter resolution layer to match the DTM. So then once you've done all that, you just need to click run, and it's a relatively small catchment. So it hopefully shouldn't take too long, but while it's running, I was just going to show you, and we'll also share this, which is the land cover classification. So this is the CH land cover classes here. You can see how they relate to the UK BAP habitats as well. So you can see the 21 classes that they've got. These are the standard Scimap risk weightings that you might have seen in other Scimap documentation or in my Scimap. And then you can see here I've just multiplied them by that factor of 100 for Art Pro to be able to reclass it, and they get divided again. And as I mentioned, all the layers are now snapping together to hopefully resolve that issue with the different extents when you load them into Saga GIS. So just while it's running, I was going to mention that Sim's got some funding to hopefully update the My Scimap, the online tool, over the next year, and he's going to be doing some sort of user feedback to find out how best to develop that. So he's going to give a presentation on that at the CDUG, the Cabot Catchment Data User Group meeting tomorrow. That I know Jane and Caitlin, you quite often attend those. But if anybody else wants to ever join the CDUG meetings, the working group, you're very welcome. You just need to get in touch with me and I can make sure you get added to the invite list. And I think he's hopefully looking to develop it to be able to bring in the Scimap flood, the Scimap FIO and the Scimap sediment risk all into one tool, so you can run it and compare the different sort of multiple benefits and multiple risks that you might have in a catchment. So that'd be really good, and I think he's hopefully looking to do a few things like improve the resolution of the DTM that's maybe available in the online tool. So hopefully it shouldn't be too long now. Did we have a question? Just Rebecca saying she's off now. So it's nearly finished now. It's just on the last process. So once it's run, if you go back to your folders and again, we're doing Scimap inputs, you can see it's outputted. We've got the ASCII files, and it's also outputted the other files before it converted them into an ASCII in case you want to take a look at them all. So once you've got your files, if we go to Saga GIS, we then need to import our data that we've got. So if we go to, you want to go to import, export grids and import Esri ArcInfo grid and double click on that. And if we navigate to where we have saved our files, so we'll start with the DTM. We need to add them one at a time. We'll just click OK. We'll add our erodibility one next. And then the rainfall. Okay, once you've added them all, if you click on the data tab here, you can check that they've loaded, and again check that they're all underneath the one grid. So those of you that used desktop Scimap before, this is something that has caused quite a lot of issues when you look at this, and maybe two of them are under one grid system and the third layer is under a different one. So hopefully this helps resolve that. So once you've added your data, you want to go to the Scimap module and click on Find Sediment Risk. So in the grid system, you want to check the one that they've just uploaded to, and then you want to tell it which file is the DTM, which has the erodibility, and which has the rainfall information in it. Then the model is going to create all these other layers for you. And I would just leave all the default settings as a set. The only one that you might want to play around with is this critical area for channels that's currently set as default of 80,000. So that determines the upstream, the size of the upstream area before it'll start drawing the channel layer. So if when you look at your results you think, oh, there's too many channels have been drawn and I don't want to see that, I want a simpler layer, then you could increase that number so the upstream area has to be larger before it'll output a channel. Or you might think, actually, I want to see some more of the channels, some more of the ephemeral channels. So they might not actually be a river channel, but where the surface water flows. So you could reduce that number and then it will output more channels. So you can play around with that, but generally find if you just leave it at 80,000, it's pretty good with the output that you get. So once you're happy with it, if you just click OK, and it will run the model. I was going to say, just while it was running this, I had a quick look at the LiDAR data, and if you want to quickly see what coverage there is, if you just copy this WS link, then you can add it into ArcGIS Online to see what LiDAR is available. So Cumbria and Lancashire still isn't the best, but I did notice that the EA have very recently added the 2020 data, so there is a bit more coverage than there was. I think I only looked at it a few weeks ago and it was still only 2019, so there is a bit more LiDAR data available now, but there still are quite a lot of gaps across Cumbria and Lancashire, but that's quite a quick way just to see what data there is available. So it hopefully won't take too much longer to run. And I think Kat's just posted another way to look at the LiDAR extents with an app from the EA, which is good. So now it's run. If you just click on data, you can see that it's output all those different layers, and you can look at them all. They're all quite interesting, but the three main ones that you want to look at from Scimap are the erosion risk, the connectivity risk, and the erosion risk in channels. So you can click on them and look at them in Saga GIS, but it's not really that usable in terms of the symbology and viewing it. So you probably want to export these layers back out into your desktop GIS. So to do that, if you go to the modules and you go to, this time, export Esri ArcInfo grid. So you want to choose the grid system, and then you want to choose the ones that you want to export. So we want the erosion risk. And again, I would probably create a file just in that same folder called Glenridding Scimap outputs this time. And this is the erosion risk that we're exporting. So just leave everything else at the default settings, and OK. So that'll export it. I'm not going to export the other two because I have got them as a test file to show you. So then if we go back to Arc Pro, I'm just going to turn off these input files that we had. And then if we want to go to geoprocessing again and search for Scimap, this time we want the convert outputs tool. So if we click on this, and then we want to set our output workspace. So I'm just going to choose, we would have set up that Glenridding Scimap outputs, but I'm just going to use this test Scimap outputs folder. Actually, no, I'm going to use the Glenridding one. If we just click that. And then if we choose where we've saved our output files, so if I just go into the test one for now, where I exported them before. Yeah, if they don't appear the first time, then if you change this from all supported just to raster type, then they should hopefully appear. So it's these ASCII files that have been exported. So if we select the erosion risk and then the connectivity one, and then the final one is the channel risk. And then you want to just select the output coordinate system to be British National Grid. And if you just click run, it will convert the outputs for us. So yeah, once it's exported them, if we just look in outputs, and if you just refresh it, you should get the outputs there, so you can see that they're there. And then if we just go to the map, and if we want to add the ones that we've got, if we add the connectivity and the erosion risk and the fine sediment in channels that's converted into a point layer for us, we can then add the symbology to that. So if we just find the colour ramp that we want to use. And zoom in, we can see the red areas are those areas of the catchment that have the greatest erosion risk, where it's connected to the channel. If we want to do the connectivity, I'd probably just choose blue for that. Oops, wrong one. The blue areas are the most connected, so that can show you areas of the landscape that they might not necessarily be high risk if the land use is fairly good there or doesn't pose an erosion risk, but they could be areas that could be subject to risk if the land use was to change. So there might be areas that you want to advise people to think about the land use and the sort of sensitivity of those areas. And then the final one is the channel one. So if we symbolize that using graduated colours, and the field that we want to select is the one that says grid code. And we could do this by quantiles. And we'll just leave it with those colours for now. And then if we drag it onto the top, so you can see that there, probably just change the symbology a bit so there isn't a black outline on the points. Shrink the points down. Then just add the colour ramp that we want back to it. That's a good one to use. So we can see that the red channels are those areas of the catchment where the channel's got the highest risk of receiving fine sediment. And then if we compare that with the erosion risk, we can see where that risk might be coming from and where we might want to look at targeting measures in the catchment. So that was just a quick overview of how the tool works.